Hello, everybody. Hope you had a good day. We are going to start by reviewing the properties of parallelograms. So go ahead and use this information to find the length of RS, and then we're going to move on to our new concept for today. Okay, so we're going to take the properties of parallelograms and we are going to use that information to be able to prove that quadrilaterals are parallelograms. So what we're looking for are these few things. Okay, so both pair of opposite sides of a quadrilateral are congruent. Okay, one pair of opposite sides are parallel and congruent. If both pairs of opposite angles are congruent, then it's a parallelogram, and if the diagonals bisect each other. Okay, but what does that mean? Okay, there are quadrilaterals that this will not work for. So these ones over here in this box obviously are going to be yeses. The side lengths are congruent and parallel, especially the opposite ones, and you can see that these are all going to be parallelograms. These are also quadrilaterals because that means that they have four sides, 1, 2, 3, 4, 1, 2, 3, 4, but they do not meet the requirements of this, of having opposite sides congruent, of having opposite sides parallel. Okay, those things have to be true in order for us to be able to prove that something is a parallelogram. Okay, so if you ever see a function or a quadrilateral like this, you automatically know that there's no way they will ever be a parallelogram. So to find that, we're going to use two different properties, using our properties to be able to figure it out. We're going to do it based on side length, and then we're going to do it based on angle measure as well. Okay, so to do that, pull up this other screen and zoom in a little bit. It's going to give us some numbers to be able to plug in and say, use these to prove that this is true. So we're going to use x equals 7 and y equals 4. That's part of what this is saying, but I'm just going to write it over here so we can zoom in a little more. So you'll notice that the x's are going to be on these two sides. The y's are going to be on this too. So you're going to be proving it 2 times because in order to be able to prove a parallelogram, you need to prove that it works for both sets. Okay, so we're going to start by the x set, and we're going to use x equals 7 to substitute in. So instead of being x plus 14, it is now going to be 7 plus 14, or 21. And instead of being 3x, it's going to be 3 times 7, or 21. And you'll notice that these two are equal, which tells us that those two are parallel. So now we're going to prove it for the y values, or these two sides, and we're going to do it the exact same way, but now we're going to use y equals 4. Okay, so 5 times 4 minus 4 for this one. 5 times y minus 4. 5 times 4 is 20. 20 minus 4 is 16. We're going to do the same thing for this one. 2 times 4 plus 8. 2 times 4 is 8. 8 plus 8 is 16. And that is equal. So therefore, we have proven that this four-sided figure, this quadrilateral, is a parallelogram. Okay? That is all you have to do. You're basically substituting in and saying, yes, it works. Okay? And lastly is what we're going to do for angle measure. So let me make this a little bit bigger for you just to see it. So angle measure, remember we're saying that opposite angles are equal, or same side interior are equal to 180. So it depends on which one you're doing. For this one, you'll notice, going the wrong direction. This one, you'll notice that our Z's are opposite, our W's are opposite. So we're going to be using the opposite angle theorem, which means that they're going to be equal. If we were doing the same side interior, we would be adding them to be 180. Okay, so let me pull up this and we will work through the angle one. Again, I'm going to rewrite up here that we're using Z equals 11 and W equals 4.5. And we can start with either one. It doesn't even matter. I'm going to start with Z just because it was the first one given to us. So we are saying 9 times 11 plus 19 has to be equal to 11 times 11 minus 3 because we're replacing Z with 11. So if we take 9 times 11, we're going to get 99. 99 plus 19 is going to be 100. Whoa, I times it. It's going to be 118. 11 times 11 is 121. Minus 3 is 118. So that one works out for us. Now we're going to do the exact same thing, but with our W's, and we're going to be plugging in 4.5. So we would say 12 times 4.5 plus 8 has to be equal to 14 times 4.5 minus 1. 12 times 4.5 is 54, plus 8 is 62. 14 times 4.5 is 63, minus 1 is 62. And again, that one checks out as well. So you guys are going to practice 2 of these, one for side length and one for angle measure. Actually, this one has both angle measure and side length, so you're going to be doing it on both. So this one, we're going to use A to prove this and B to prove this. Now, these are same side interior, which means they need to add to be 180. So go ahead and substitute these values in, see if our side lengths are equal, and see if our angles add to be 180. Okay, so now you guys are going to try it for this one. This one is dealing with our diagonals. And remember, diagonals are directly cut in half. So we're saying that this half is equal to this half for the x's, and this half is equal to this half for the y's. So go ahead and use x equals 6 and y equals 3.5 to solve for that. Okay, so hopefully this was a fairly simple concept for you guys. You do have an exit ticket that is going to be 8 different questions for you. You do need to score a 6 out of 8. It is practicing this exact same concept. So hopefully it will be straightforward for you. Please make sure both this Ed Puzzle and exit ticket are done by the end of your period for credit. Alrighty, have a fantastic day.